For those that don't know, here's a brief little Wikipedia entry. We're essentially a derivative operating system based off Android. We add other features, but we're mostly free and open source, and we support 160 plus devices versus like Nexus AOSP program, which is about 5 devices. Our contributor base is massive. As you can see the SID head over here. Every single line in there is a name of contributor over the past 5 years. In total, we have about 1,253 contributors. That's as of August, with about 47,000 commits that's not in AOSP. So it's quite a large delta. But essentially what we do is crowdsource Android development. We get community changes that are incoming. We roll them into our nightly release builds, and those actually ship on devices every single night. Today, however, we're going to be talking about how this delta grew a little too large and became a little bit unmanageable. First, we're going to be talking about our Tree Hacks hackathon learnings. We went to a Stanford hackathon. We learned a lot of things that we were a little bit ignorant about. We realized that OS and framework development is really intimidating. There's a lot of work, few rewards, and essentially we came up with a solution that can help us get through it.
So, hello. You guys hear me now? All right. So Tree Hacks was a weekend-long hackathon back in February, and that was at Stanford. So there was like 670 kids who attended, and you can imagine there were some smart guys there. There's applications from all over the United States. So we had 2 guys submit an entry using the CyanogenMod platform, and we went there, and that's what we tried to do. We wanted to get people to hack on it. And so we had 2 entries. Here's the winner, CyanogenTranslate. And these guys built, they went from syncing the source to building it to adding a whole new feature in 3 days. And we learned that that's a lot to do and a lot to kind of absorb in just a short amount of time. So these guys had basically just 1 day they spent trying to get the source. We bought some hard drives to make it go by faster, but CyanogenMod source is 25 gigabytes. It's going to take some time. And then they spent the next day kind of getting familiar with it, with the build system, trying to figure out the different quirks. And they didn't have that much time left to code. They didn't need it, to be honest, and that said something to us. So overall, we had a great time helping the kids, getting it set up, but we noticed that most of the time we weren't helping them with very Android-specific things that we were there for. We were helping them set up with the build system and just weird little quirks and things like that. So this is their project. I hope it plays. There you go. So what these guys did was they came up with an on-the-fly translator. They hooked into CyanogenMod, and they hooked it up to Google Translate. And so it works from the MMS app, and they're going to show you how it works from the web browser. And they did this in a span of 1 day. So next slide. So we got a lot of feedback from these guys, and it was great. They love the open platform. They love that they could just go and contribute to our Garrett and see all the submissions, and everything's on GitHub. They can go sync. They can go look at the code. We even have some documentation that helped them get started, but it wasn't enough. But some of the downsides that we saw was that it took them way too long to get started, and that's something we took to heart. We want to fix this. It's a huge code base. It's 25 gigs of source, then you have another 50 when you're building, and then there's 100 plus just packages you just have to look at, and it's a ton of code. And the thing is the barrier of entry is it doesn't have to be that high. And we really tried. We took this feedback to heart, And we went and we asked ourselves, we came up with these questions on how do we improve this experience. We wanted to decrease the barrier to entry to allow these kids to not have to have all this tribal knowledge of how the platform works to submit a feature. We wanted to help streamline the process and formalize it on how people contribute to us. And also, we wanted to kind of stabilize our own interfaces inside. Like, if we wanted to use our own features, we could, but what if the versioning's changed, and what if we changed something on a device we shipped and our code didn't, we didn't have these things figured out quite properly. So, I mean, this is the moral of the story. OS development is intimidating. I mean, if you've ever managed to include a fully functioning interface, you'd be one of the few people who understood the process and from like a full stack perspective, and that's kind of a hard thing to do. So one of these biggest features in CyanogenMod was the profiles contribution. So profiles was added by Martin Long in 2014, and profiles, you could essentially register for specific events in the system, and then you could configure your device to react to them, right? So for example, here's an example of a user creating an action to be triggered by an event. So specifically, the event being a Wi-Fi SSID connect event. So from the settings app, the user is setting up on the Wi-Fi connect of their choice. When the SSID connects, they hit the profile service tells the system, hey, when this Wi-Fi SSID connects, send it back to the profile system, and the profile will trigger the actions back that the user has selected. So could my app have used this profile system? No, not without weird, crafty Java reflection, which we try to avoid as much as we can. Per the Android compatibility documents, they say that any public method in the Android namespace that is not a part of the public Android API, must be marked with the @hide annotation.
Yeah, so the dreaded @hide. @hide essentially is just a Java doc annotation specific to Android build time. The way it works is any methods you don't want in the public API, you annotate them with @hide, and then during compile, they get stripped from the method stubs, from the API stubs, they get stripped from the Java docs, and essentially it's only accessible via reflection during runtime if you're creating interfaces that way, which is bad practice, I guess, for us. What implications that had for us? Something like profiles, if we wanted to extend that to, let's say, applications we were working in separate teams or with someone externally, we couldn't actually do that because there would be no stable interfaces. I couldn't tell you that, hey, make this API call, you'll get this result back, because we didn't have any explicit versioning at that time. It also made QA really a horrible experience because we couldn't set any testing expectations based off versioning releases. And then honestly, just horrible rebase conflicts. Every single time a new version of Android came out, we'd have to go and pretty much replay all the commits that created the service and everything that came on top of it. It just became way too much. So with that, we kind of sat down and said, how do we get around this? So we came out with the CyanogenMod platform. So it's a new, more approachable infrastructure. And the way it works is we kind of duplicate the Android framework. So we essentially have 3 components here: the platform library, a secondary resource package, and then a statically linkable SDK. The platform library essentially hosts all the system services that we get spun up by the system server within Android. So pretty much anything that does state management, like the profile service, or anything that we need to rely on being there and interacting with, is hosted and lives here. But yeah, we're just leveraging Android's powerful IPC framework for that. Secondly to that, we also have a resource package. So if ever we want to, just even have like a system label that we want to reuse across applications, we now have a very specific identifier we can query those resources with, or drawables, or anything in between. We can also declare our own permissions that we carry on forward without platform releases. But the biggest point here is the platform SDK. So this is essentially a jar you can just toss into your project. These are the stable interfaces that can invoke these system binder calls, and you'll actually have access to these features. And this actually goes on a rolling release schedule. So we take this new platform, we go back to the hackathons recently. We actually did another event that's done by IDEA. It's called Code Rush. And then we went down to Mountain View for Hack the Planet, which really smart kids there. Came up with a lot of cool projects. And our feedback was a lot different this time. It's consumable, ease of use gets tossed around. Our bottlenecks ended up just being logistics. So we didn't have enough CM devices there, and we didn't have emulator images, which we're working on currently. But yeah, one such contribution we had from one of the interfaces we added is we allowed the user or the developer now to create tiles programmatically. And one team who was creating a QR code application, essentially a Bitcoin wallet, they said, oh, it'd be great if I didn't have to go access my app and go all my account settings and go find this QR code. So essentially, they just published their QR code to a quick settings panel, go in the expanded mode, and anyone can scan it. So it's things like this that we can allow now. But yeah, Roman's going to cover how to actually utilize the SDK in your app.
So utilizing it is actually, I had a good experience trying it the first time after everything was in place. Like it was just as easy as I'd hoped. So all you need to do is fire up Android Studio, start up a new project, and you're ready to go. You add, so we have our version 2.0 is our stable release right now of the SDK. And to compile against that version, you would include the compile or CyanogenMod platform. You hit version 2.0. We are on a rolling release. The next version will be 3. So if you want to work against our development branches, you can set that up in your build.gradle. And now you can use the SDK. All you have to do is define the dependency in your build.gradle, and Maven will pull it down, sync it, and you can hit our SDKs. So I'm going to jump right into the code here of how to add a custom tile. So this works very similarly how you would post a notification. So when you click a notification, an intent gets fired. And so the first thing we do is we need a pending intent to wrap it. And you can see I'm creating a new intent there with a custom action that I'll be listening for later on, and I can respond to. Then I use the custom tile builder to create the tile. I give it the label, the icon. I tell it I want it to collapse after I click it for my specific use case. And then the last thing is I can just tell the CM status bar manager to go, hey, publish this tile. I give it a unique identifier within my app, and it will show up. On the other end, responding to a click of the tile, you define that listener that in the Android manifest that listens to the action which I defined in the intent in the previous slide. And then in the code, all it's doing is it just removes itself. You can come up with whatever you want, use your imagination. There's so many things you can do. Now, I kind of want to bring this back to the profiles. So CyanogenMod ships with 3 profiles by default. There's an automobile one, a default one, and the silent profile. I usually set my car up to automatically switch to the automobile one when it hooks up to my car Bluetooth. But I kind of wanted it to do something more. Like sometimes in the car, I wanted an icon to show up so I don't have to go digging through all my apps. Like, maybe I want to open Google Maps or something. So to do that, you can listen for profile state changes. And you get sent this intent, which is in our SDK. You listen for the profile selected intent, and then when I receive that, I know the profile has changed, and I'm going to act upon it. And in the code, notice how similar this looks to the other slide, and I wanted it to be just that simple. All we do is we check if the car profile is active. If it is, then publish my car custom shortcut tile. If it's not, then it gets removed. It's just as simple as that.
But yeah, going back to then, how did we deal with creating a versioning system? So we kind of decided to mirror the entire build class from Android. If you're familiar of checking API levels programmatically, this is one-to-one from that. Essentially, what we're querying is an SDK integer that's exported as a system property from the file system in your current environment or whatever device you're running on. And you can query against a hard-coded API level to see if a feature is available. So this way, we can actually check, like, hey, are we running on a CyanogenMod device at all? And if we're running on a CyanogenMod device, is it an API level that's greater than when this was introduced? And that essentially allows us to interact with the profile service. But yeah, currently we're on API level 2 as our stable release, which is called Boysenberry. We have a lot of features actually included in there, and we continuously add a lot more. Every single quarter, we will publish documentation on this. And currently, we also host full Java docs on GitHub. But yeah, contributing is still very much similar to how it's always been to CyanogenMod. And it's very core and fundamental to how AOSP has worked. You essentially repo in it the main manifest, you pull it down, repo sync it, and you start your local changes. You contribute it back to us, and we actually put this under a little bit more scrutiny than we do other code, mostly because we want to retain the compatibility, mostly in terms of CTS. For those unfamiliar, CTS is a certification testing suite that Google has you run to make sure that you can actually get GMS services and things like that. So we make sure that all those interfaces are stable before we even look at your code. We'll actually ask you to write unit tests. We'll pretty much have you put in all the legwork to make sure that your contribution is stable. Then if it does get included in, you become part of the rolling release. And then at the end of the quarter, usually your feature gets included. We actually had a guy from Portugal. He was very big into multi-sim. At this time, Marshmallow was not released. So he wanted to have multi-sim APIs. So he pretty much wrote his entire interface so his application can talk to his own interface that he created in the operating system. And he actually released his app on the Play Store recently, and he contributed that full interface to us. So, yep. Yep, but for now, I'm going to open up the floor for questions, if anyone's got some. Steve? When they will support what? Oh, rich content? So, you know more, the people in this
Working
room.
in progress.
So on a staging branch right now, we have a pretty cool feature. Essentially lets you render an external processes surface within a view container in your hierarchy. So it lets you actually get like rich content. If you wanted to render like a map view from another app or get that bound into your view hierarchy, it's actually something we're actively working on.
So I put up some samples for my code that I have. It'll actually run, and it'll actually publish a tile that you can play with. Here, the link is down there, the bit.ly link. And the CM SDK, it's got a wiki. I encourage you to go there. Wiki, API links. It's got great documentation. Yeah, highly encourage you guys to go check it out.
Thank you guys for coming up.
Thanks.